Good afternoon. I'm going to go back over the examples from Friday in case you're having any trouble with this. On Friday, our learning target was I can solve polynomial equations. I can solve polynomial equation. We're already working with some polynomial equations this year in Math Workshop, particularly quadratic equations. Well, today we're going to go from quadratic to cubic to quartic and so forth. First thing, no matter what type of polynomial equation you're solving, whether it be quadratic, cubic, quartic, or quintic, they have to be set equal to 0. Remember, you cannot factor until the equation is equal to 0 or solve them until they're equal to 0. Alright, so let's look at the first one. These first few should be easy to you because we already did something very similar to these this year. Okay, this is a difference of squares. It's quadratic. It is in standard form, and we know it's in standard form because it's set equal to 0. So simply you just factor it. You set both of them equal 0 and get x equals 3, x equals negative 3, and x equals 3 as your answers. This is a quadratic equation. The maximum number of solutions, or the maximum number of zeros, which is called the maximum number of zeros we can have is 2. We don't always have to have up to that many, but we do have 2 in this case. Number 2, it is in standard form. It is a quadratic. So I'm trying to factor it. But the reason this is not different squares like this, remember the word difference of square means subtraction. That's a plus, so it cannot be difference of squares. It's not bust them up. It's not easy. It's not grouping. The last resort is GCF, and we can't do that. So this is not factorable. Not factorable. Now I'm going to show you 2 ways you can work this. My way I always work this is quadratic formula. So I'm going to write this problem over here. Quadratic formula, identify your A is 1, your B is 0, and a C is 9. You see, Mr. Tesher, why is the B 0? The B is the coefficient from the X term. There's no X, just X term in there. There's an X squared. That's your A, no B, and C. Remember quadratic formula, opposite of B, plus or minus. B squared minus 4AC all over 2A. Opposite of B, well, opposite of 0 is just 0. Plus or minus 0 squared minus 4 times 1 times 9 all over 2 times 1. Gives me 0 minus 36, which equals plus or minus negative 36 over 2. Okay, there's a negative under it, even radical. Therefore, these solutions are complex. These are not real. These are complex. Therefore, they're imaginary. You will not see them if you were to graph this function on the graphing calculator. You will not see them because these are imaginary. So, the square root of 36 normally is 6, but since there's a negative there, I'm going to make it 6i over 2, which equals plus or minus 3i. That is 2 imaginary plus or minus 3i. Now, he's a Mr. Tesher. I just did this. Brought the 9 over and got negative 9. Take the square root. I will allow you to do this. However, remember, when you take the square root of this, negative 9 is plus or minus 3i. Most times students leave off that plus or minus, just put 3i. Imaginary numbers come in pairs, so that's why you have the plus or the minus. But the only time you can do this shortcut is when you have a variable square and some number you can just move over. That's the only time. The rest of the time you have to do the quadratic formula. So in this particular function, this was a quadratic. It could have up to a maximum of 2 zeros. It has 2 zeros. 3 plus or minus 3i. Now, how many real zeros does it have? 0. How many complex? 2. It has 2 complex and 0 real. Alright, let's look at number 3. X squared minus 9x. This is not different squares because this x is not squared. So the only thing you can do is GCF. I'll take an x out. Now this was quadratic. It was a standard form because it said equal to 0. Now it can have up to 2 zeros. Either it's real or some can be real, some can be complex. Just know it can have up to 2. Okay, there's an x here, so I need to set that equal to 0, and then x equals 9. In this case, it has only 2 real zeros. There are no imaginary, just 2 real. We're going over number 4 later. Let's go on to number 5. I'm going to write this problem down on notebook paper. Number 5. 8x cubed equals 27. This is a cubic. It is not in standard form. I must get it in standard form. Now, we talked about this on Friday. Unlike squares, you can only have difference of squares. You cannot have. You can only have difference of squares. But for cubes, because you can have positive and negatives under the radical, you can have sum of cubes and difference of cubes. Okay, this is going to be a difference of cubes. Now, you need to remember your perfect cubes at least up to 6. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. Now, when you factor a difference of cubes, you have a small parentheses, a binomial, and then you have a trinomial. Okay? First thing you do is you take the cube root of everything in the original. Cube root of 8 is 2. Cube root of x cubed is x. Cube root of 27 is 3. We're going to come back and do the signs in a minute. That's your binomial. Now come over to trinomial. To get your first trinomial is 3 terms. To get your first term, you square this first term over here. So 4x squared. Multiply these two together as 6x. Square the last, 9. Let's go through it again. To get this parentheses here, I took the cube root of everything. To get the trinomial, I squared this first term. Multiply these two together to get this. And I squared this over here. Now, I'm going to use the method SOAP to determine my signs. So, same, that's a minus, same as the original, same. Opposite of my original goes there, always positive. Okay? I set this equal to 0. Move to 3 because of positive. You should be able to know that's 3 halves. 3 halves. This is a real 0 because there's no I. That's real. Now let's see what we got going over here. This appears to be bust them up. I multiply 4 times 9 is 36. Got to multiply to give me 36. Add to give me 6. Well, there's no two numbers that do that, so I'm forced to use the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. Opposite of b is negative 6 plus or minus 6 squared minus 4 times 4 times 9. All over 2 times 4. Negative 6 plus or minus 36 minus 144. I'm going to bring this up here so you can see it. So that gives me negative 6 plus or minus square root of negative 108. Okay, now that you see a negative in that radical, you know that this is going to be some complex zeros, some imaginary zeros. So I'm going to break 108 down. I'm going to come over here, do a factor tree. That's 12 times 9. 12 breaks down to 4 times 3. 9 down to 3 times 3. A pair of 3's and a pair of 2. So 2 times 3 is 6. I bring that out with an I to combat that negative. Now, before I submit this, I can take something out of all three of these numbers. I can take a 2 out, so it's negative 3 plus or minus 3i all over 4. Now, in my original problem, I could have up to 3 zeros. I have 3 zeros. This is 1, and this is 2, 3, because you have the plus or minus. Now, let's classify them. How many real do I have? 1. How many complex? 2, because these are imaginary. So 1 real and 2 complex equals a total of 3. If you were to graph this, you would only see it cross that x equals 3/2, which is 1.5. Let's look at another one of those. Number 6, off that same page, page 19 notes. Okay, before I get started here, if I went through all those, I can't do sum or difference of cubes right now because 4 and 32 are not perfect cubes. It's not different squares. It's not bust them up. It's not easy. It's not grouping. The only thing I can do right now is GCF, so I take a 4 out. It is in standard form, being set equal to 0. The maximum number of zeros I could have is 3. Alright, once I take that 4 out, because it does not have a variable there, I do not have to worry about that. Now I just got x cubed minus 8 equals 0. Well, x cubed and 8 are both perfect cubes, so I'm going to have small parentheses for a binomial and one for a trinomial. First parentheses, you take the cube root of both terms, x cubed, cube root of x, cube root of 8 is 2. So I have my binomial. Remember, I'm going to come back and do my signs in a minute. Trinomial, you square the first one. Multiply these two together. Square the last one. Once again, to get this, I square the first one, multiply these two together here, and square the last one. Remember, so that's how we determine our signs. Same as original, opposite original, always positive. Let's set the first one equal to 0. That would be easy. X equals 2. There's one real for sure right there. Now, that appears to be easy. But once I try to factor it, I can't think of two numbers to give me 4 and add to give me 2. So I'm forced to do the quadratic formula. Opposite of b, that's negative 2 plus or minus 2 squared minus 4 times my a value of 1 times my c value of 4. All over 2 times 1. So I have negative 2 plus or minus 4 minus 16 over 2. Negative 2 plus or minus square root of negative 12 over 2. I have a negative under my square root, therefore I know these roots will be complex because they're composed of an imaginary unit. Okay, I'm going to break 12 down. That's 4 times 3. I have a group of 2's. So I'm going to bring that out as 2i, leaving a 3 under the radical. I can take a 2 out of all this. That leaves a negative 1 plus or minus I square root of 3. You have to put that over 1, and because there's an I there, there's an understood 1 there. So I divide everything by 2 and got negative 1 plus or minus I square root of 3. Because that leaves a negative 1 of 1 that's understood there over 1. You have to put something over 1. So how many zeros do we have? We have 1, 2, 3, because of plus or minus. Now how many real do we have? We have 1 real and 2 complex. Number 7 is as far as we got on here, and we'll pick up on this tomorrow, but let's look at this one. This is a quartic. To begin with, I could do GCF. It is in standard form, set equal to 0. Highest degree is 4. That means it can have up to 4 zeros. Alright. Now, what I'm going to do here is take out go through all my factoring. I can't do different squares, sum of cubes, different cubes, none of that. Can't do bust them up. Can't do easy. Grouping, no. So I'm left with just GCF. I take an x squared out. Okay, I'm going to set that x squared equal to 0. X equals 0. Because that was x squared, that has a multiplicity of 2. Reviewing that. That means what occurs there if it's got a multiplicity of 2. Hope you're thinking bump. That's correct. Now the other one, this is easy. So I multiply to give you 21, add to give you 10. So that would be negative 7 and negative 3. So in this case, I have 3 zeros. I could have up to 4. But I have 3, 0, negative 7, negative 3. And in fact, they're all real. There's no complex. Alright, so we'll pick up with this tomorrow. But that was just what we did on Friday.